Hi, I'm Rebecca Duffy, an application scientist with ZEISS Microscopy. Today I'm going to be showing you how to use Dynamics Profiler on your LSM 900. Dynamics Profiler has added a new way for us to measure and gather information about concentration and dynamics of fluorescent proteins in our living systems. Some of these include measuring concentration and general diffusion and mobility metrics. Some of those new frontiers include looking into cell compartments, measuring diffusion kinetics at membrane barriers, as well as looking at condensates inside of cells. And what we're going to talk about today is how we can use Dynamics Profiler to measure active movement or flow within living systems, and even validate microfluidic systems. So before we get into that, I really want to talk about the general FCS principle and what we did to take some basics in fluorescence correlation spectroscopy and then apply that to a whole new space. So in general FCS, you're going to park your beam on one spot, and you're going to measure and count fluorescent molecules coming in and out of that singular spot over time. But you're limited to just that one spot at a time. It makes repeatability very challenging, and it also means that you aren't going to be able to gather information on what's happening in and around that spot as well. So what we did was we took that basic principle of photon counting in a singular spot, and we then used our Airyscan detector, which is a 32-channel spatial array detector, to gather much more information about molecular dynamics that we're able to pick up on that detector. So now we aren't limited to measuring one singular spot, but we can measure 32 different spots with each of these little units that look like a honeycomb, measuring 0.2 area units on our detector. So now we're able to gather a lot more information, and that's how we are able to extend beyond general concentration measurements and diffusion coefficient calculations into a much broader space of what's going on in our living systems. So one application space that I'm really excited about, coming from a biomedical engineering background, is microfluidic systems. A lot of people are trying to do organ-on-a-chip technology these days, and a big question that often comes up is what flow or shear stress or dynamics are the cells in that system actually experiencing? And now we have a way to help validate that. You can take something like rhodamine dye, flow it through your channels, and then actually measure the speed at which those channels are having flow, depending on how your pump is modulating. And here's an example where you can see where the channel border is, and we're measuring 10 spots at a time, and you can start to measure the flow profile across your channel and make sure, for instance, that you are in fact seeing laminar flow across that channel. Not only will you get out the actual direction, which you can see here in this nice graphic that we have showing the direction across the detector that your flow is moving, but you'll also get an actual readout of the speed. And so, but of course it's not limited to just microchips and microfluidic devices. It actually adds a whole new dimension into living experiments where you might want to measure, for example, the flow in a capillary, in this case of developing zebrafish. So here we can zoom in to some of the capillary network in our living organism, and we can actually measure the flow of blood in that zebrafish. So really exciting, whole new space to be able to easily measure flow in a system. In this example, you can see we have two spots measuring flow at different speeds in microns per second. And of course, again, you not only get the flow speed, but you're going to be able to see what direction it's actually going in. And of course, that does track here from the graphic on the left to the actual infographic on the right, showing the blood is pumping from left to right, which you would expect from the orientation of the fish. But you can now confirm all of that and get real measurements in your living organisms just using Dynamics Profiler. So why don't we go on and hop over to the software, and I'm going to actually show you how we can do this in a microfluidic chip. As you can see, we have a microfluidic chip set up on our LSM 900 with Airyscan right now, and I have a flow of fluorescent rhodamine currently going through that, so that's going to be our fluorescent dye of choice that we're going to use to validate our flow measurements in this chip. Something that we're going to do right now to make sure that we know we're in the channel that we want to measure our flow in is I'm going to use my wide field camera to go ahead and take an overview image of my chip. I found sort of the top channel up there, and I know that I'm in the third channel, so we're just going to get a quick overview of where all of these individual channels are. That way, within Zen, you can have this really easy way to contextualize your experiments. You can switch over from your wide field camera back to your super resolution Airyscan mode, which is what we'll be using for Dynamics Profiler. And that way you can actually see what's going on. Here I'm just using a coherence contrast method, which is actually using our AI sample finder red LEDs to give a gentle illumination and have some contrast so that we can actually see where our channels are in this microfluidic chip. Okay, now that we've done that, I know that I'm flowing rhodamine 110 dye through this third channel here, so I'm actually going to switch back to a 63x objective, and then I don't have to actually lose the context here. I'm actually just going to move out of the chip. I have a little apply immersion macro that we've developed here, but you could certainly just double click off after going to load, basically what this immersion macro does, so we can apply our water. And I can hit OK. And now we can double check that we're exactly where we want to be in our channel for measuring flow. Right now we're in the middle. If we wanted to double check that we are actually where we think we are, you can double click up here and you can see that I'm aligned. My border is exactly where it should be. This is why 𝗏centricity and 𝗏icality are your friend. And let's just measure in the middle of the channel here. So we're ready to go. Now that I'm in focus, I actually want to double check that we're actually at the surface of the glass. We could do that two ways. I can use definite focus to find the surface. And if you don't have definite focus equipped on your system, what that does is it's looking for a difference in refractive index between the glass and the water. But if you don't have that, that's okay. You can also just go into reflection mode here to verify that you're at that border. And then you do want to make sure that you're about 70 or so microns into the fluid. Okay. Now we just hop into the wizard, and it's going to basically take it from here. We're going to do an Airyscan detector adjustment, but don't worry, it'll never let you forget that step because it's built into the wizard. It's going to make sure everything is nice and aligned so you're getting as accurate as possible of measurements. And then we can always take a reference image. In this case, we're not going to see a whole lot, right, because we're just looking at dye. But it's really helpful when you're looking at any sort of organisms like cells or zebrafish. Maybe you're trying to measure flow in zebrafish capillaries. Super helpful there. And now we can just add or delete and evaluate our different spots that we want to measure. We'll just add a few here. This evaluate spot button is great because it's really going to make sure that we have enough counts per molecule to actually have accurate measurements. You get that green check mark, you know that you are good to go, and you're going to get some great data out of your detector spots. If it's not, you can also see sometimes a yellow or red even. Yellow is acceptable, but red means that you really aren't getting enough information. You either need to adjust your correction collar or tweak your laser in order to really make sure you're getting enough CPM. But everything is green here, so now all we have to do is make sure we're happy with our measurement time. 10 seconds should be more than enough. You could up this or lower this. I would say 10 to 30 is pretty standard. And if you're worried, again, about anything moving, you could hit snap again. We won't really see a difference here because we're just looking at dye and solution. And now we're going to hit start our experiment, and we're going to see what sort of flow measurements we're getting. And we can validate if we're actually seeing laminar consistent flow across the channel of this microfluidic chip that we have here. And so while it's actually taking those measurements, you can keep an eye on your count rates here and your correlation curves. So if you're ever having any sort of drift issues, it'll become very apparent if these shift significantly while you're taking them. But it's just that easy. You can walk through a wizard and you're going to measure flow as well as diffusion and concentration rates in a system, just with a few button clicks. ta-da, it'll take a post-acquisition image. Again, that really helps when you're looking at anything live to make sure that you didn't have any sort of drift or anything. And now we have our dynamics profiler results. Okay, so again, you're always going to get this correlation, diffusion, and flow. You're going to get all three of these tabs all the time. It doesn't matter what your intended experiment was, which is really great if actually you're looking at data and you need to go back and open something again later. And I'm going to do one component 3D because that is basically the system that we have here. We just have free diffusion. If we actually wanted to get any of our correlation curves, so diffusion coefficient, diffusion times, those should all be similar here because we shouldn't really see a difference from closer to the top to the bottom of that chamber in the chip. But if you wanted to check that stuff, you get all that data here. But what we really wanted to see today, right, was if we can measure flow and how easy it is. Click on that flow tab, and there you go. You can see that we are flowing from right to left in this chip. And it looks the same approximately for each of these, perhaps within 1 degree measurement difference. But it's a really nice infographic. You can see the arrows, which way they're pointing across the Airyscan detector and which way the flow is going. And then of course you have your flow speed here. This is measured in microns per second, so you may want to do a little bit of back calculation if you need to correspond that to anything. The speed is moderate. I'm flowing this at 100 microliters per minute. So let me go and change the flow on that, and we can take the exact same measurements again. So this is really great for, let's say, again, you're trying to validate a chip, and you might need to, check that as you ramp up the flow, that you're not seeing any sort of turbulence, or ramp down the flow, it's behaving as you expect. It's a really great way to validate that, and also make sure that you're keeping these in the same spot every time. Something that you didn't see when I first walked through the wizard, I didn't really highlight it, is that we can actually keep these measurement points the same if we do back-to-back-to-back repeat experiments, which is, again, really helpful when you're in something like this microfluidic chip, or even if you're measuring flow in a living system. Let's say you're looking at blood flow in zebrafish, like that example earlier. You're going to be able to do those repeat measurements and really capture what you need in a repeatable way. Okay. All right. So that's basically how easy it is to use Dynamics Profiler to measure flow on your samples. With that, if anybody has any questions, please feel free to write them in the chat. We're here every week across all imaging modalities, from light to X-ray to electron microscopy, not only to show you what's new and upcoming with ZEISS, but also to be here to support our customers and have you guys ask questions for whatever you're facing, whether it's related to the topic directly or not. That's totally okay. So if you have any questions, please put them in the chat. And just while I'm waiting to see if anybody does have any, of course, we always have upcoming workshops here at the ZMCC in Dublin, both virtual and in person. So, we're not just requiring you to fly out here, although we would love to have you visit us in sunny California. You can also join our virtual workshops, sit right on your instrument, and click with us along on your experiment to learn best practices and basically how to do some of the most challenging stuff that you guys are trying to do in your research. You can always find new and upcoming ones at our link here. And then, of course, the ZEISS portal, if you're not already registered, that has a bunch of how-to videos, resources for you guys that are our customers. So definitely use that as your resource. Basically, little link is here. I'm trying to move my head so I'm not in the way. And then any upcoming live streams, of course, you're on the streaming channel right now, but we have, I believe next week, we will be going over the lattice-sim 3 and how easy it is to get really big, fast volumes of your tiled images using lattice-sim and what that looks like. And then, of course, we have similar concepts, but on an electron microscope, so on our 𝗶হি𝗰𝗶𝗹𝘀, our Gemini 460, how to use that system to take large area, high volume images at high resolution. So feel free to drop in for those. And I do have a question. Is there any difference in the use of Dynamics Profiler for fluid flow between the 900 and the 980? The answer is no. So basically, if you have a 900 or a 980, both of those are capable of being outfitted with the Dynamics Profiler, and you're going to get the same measurements on either system because they're both using the Airyscan detector. It's basically the same across the board. It'll just be specific for what objective your Airyscan detector is designed for on your 900. But nope, there's really no difference between those. So, all right. Well, thanks for your attention. And I believe we actually still have left up, as a treat from being off for the July 4th holiday for our live stream, we also have the sister episode of microminutes to this one, which is Dynamics Profiler, but doing it on live cells. So we'll probably leave that up for the next 24 hours along with this stream, just in case anybody's interested in seeing sort of how these different modalities in Dynamics Profiler complement each other. With that, have a great